So this question is asking us to do a number of things. I'm given the equation of a curve, and I am told I want to find at the point x equals 0, the slope of the curve, an equation of the tangent line, an equation of the normal line, and then I need to put it on my calculator. So where I like to start these problems is finding the limit that's going to give me the slope at any point on this curve. So what I want to find is the limit as h approaches 0 of f of x plus h minus f of x all over h. That is the limit that will give me the slope of the tangent to any point on this curve, at any point on this curve. So my equation is f of x equals x squared minus 3x minus 1. So what I want to find is the limit as h approaches 0 of x plus h squared minus 3x plus h minus 1. That's f of x plus h minus, and I'll put this in brackets here so that I can keep track of my negative signs, x squared minus 3x minus 1. That's f of x, and that is all over h. So let's kind of work on this a little bit. Finding the limit as h approaches 0 of, well, this term here is going to turn into x squared minus 2xh, I'm sorry, plus 2xh. Plus h squared minus this term, 3x minus 3h minus 1 minus x squared plus 3x, carrying the negative sign, plus 1, all over h. Well, I have a positive x squared and a negative x squared, so those go away. I have a negative 3x and a positive 3x, and those go away. I have a negative 1 and a positive 1. Those go away. So now I'm finding the limit as h approaches 0 of 2xh plus h squared minus 3h, all divided by h. I think I'll do limit as h approaches 0 of, I'll take an h out of my numerator, so I have h, and then I have 2x plus h minus 3 over h, and now those h's cancel out, so I'm finding the limit as h approaches 0 of 2x minus 3 plus h. So that gives us the equation to find the slope of the tangent line at any point x on this curve. And that answer is 2x minus 3. So what then is the slope when x is equal to 0? Well, I have 2 times 0 minus 3 equals negative 3. So the answer to our first question, the slope of the curve at x equals 0, is negative 3. Now moving on to part B, how do I find an equation of the tangent line? Well, I know that this is my function right here. And I know that at x equals 0, I can evaluate it for x equals 0, and I get 0 squared minus 3 times 0, minus 1. So if f of 0, where x is equal to 0, my f of 0 is equal to negative 1. So I know that on my curve, I have the point x equals 0, y equals negative 1. And that is the point I'm looking at for where my tangent line will touch. Well, I know the slope of my tangent line is negative 3. I know I have this point, so I can use the point slope form of the equation of a line. Y minus y1 is equal to m times x minus x1, and find out y minus negative 1 is equal to negative 3, my slope, times x minus 0, my y value. So I have y plus 1 is equal to negative 3x. Y is equal to negative 3x minus 1. This is the equation of the tangent line right there at x equals 1. X equals 0, sorry. So let's write that, negative 3x minus 1. Negative 3x minus 1. Well, the normal line is simply a line, let's go y equals, let's make it look nice, y equals negative 3x minus 1. Y equals negative 3x minus 1. The normal line is simply a line that is perpendicular to the tangent. So that shouldn't be too hard to figure out. If I know that my tangent has this equation, I know that the slope of the tangent line is the negative reciprocal of the slope of a line. So the slope of my normal is equal to positive 1/3. It's going to pass through the exact same point that the tangent line did. So I have y minus negative 1, y minus y1 is equal to slope 1/3 times x minus x1. So y plus 1 is equal to 1/3 x. Y is equal to 1/3 x minus 1. The last step is to enter it into my calculator. So I entered the first line is the formula of the equation. The second line is the formula for the tangent line. And the third line is the formula for the normal line. So let's go zoom 6 and see what it looks like. Here's my equation. Here's my tangent line. Here's my normal line. Now you'll notice it doesn't really look perpendicular, does it? But that's because the TI calculator, the normal viewing window is rectangular, not square. In other words, the 10 points on the x-axis from here to here are much longer than the 10 points from the bottom to the top. So if I want to look at it in a square screen, I can go zoom 5, which is square. I have more points along the x-axis, but the perspective is a little bit different, and you can see now that it is actually perpendicular. And if you really wanted to zoom in on it at x equals 0, you can make your x minimum like negative 5 and positive 5, and your y minimum negative 5 and positive 5, and then graph it. And you can kind of see where that they are all kind of being tangent right there at x equals 0. I don't know if I can make that a square screen with a different window. So that's how that problem works.